This is problem 29 in chapter 2. And I'm going to, need to extend. I'm going to go ahead and work through this. It's on page 50. If you haven't read the question, please read it again. But the idea here is that there is a person in a car. They see a red light. It takes them a little time to react. They step on the brakes, and then they're going to come to a stop. So in my picture here, I'm going to have a car and a car and a car, because we're going to have a couple parts to the trip. The first part is where we have the 0.53 seconds, where they haven't reacted yet. So they see this red light, and they're like, oh my gosh, I got to step on the brakes, but they haven't started slowing down. So in the problem, it says they're traveling at 20 meters per second. Well, that means they're going 20 here, and they're going 20 still here, because they haven't stepped on the brakes yet. Then they step on the brakes, and they come to a stop. So we have two different phases here to the trip. And in the question, it tells us that we have an acceleration or a deceleration. We have an acceleration of 7 meters per second squared, and that'll be this way. So 7 meters per second squared to the left. So the thing, since the velocity is to the right, it's going to slow down and come to a stop. Breaking this up into two parts, we're trying to find the stopping distance. So I'm going to call this my x1 and this my x2. So to get stopping distance, I'm going to have to add x1 to x2. So I got to figure out both of these to get my answer. The first part is easy. If our velocity is staying the same, our acceleration is 0. Anytime this is the case, I can write this equation, which comes from any one of the motion equations. That doesn't tell you 5 equals 5. It'll turn into this, or 5 equals 5, the equivalent of. So we go ahead and we can plug and chug into that. So we have 20 meters per second times our 0.53 seconds. So, I mean, that's about 10, but let's get what it really is. 20 times 0.53, so 10.6 meters. So that's the first part. That's my x1. All right, so I've got my 10.6 meters, that constant velocity part. We're just going along at a steady pace. Now for the second part, I'm going to have to list my 5 variables because we do have this acceleration of 7 to the left. I didn't write it, but I am going to call, I'm going to do it right now, right positive, and I'll list my variables. So x minus x naught. So this is for that second part of the trip, which I called x2. So x minus x naught, that's my x2. Initial, final, acceleration, and time. Acceleration, 7 to the left, so negative 7. And again, the 7 was given in the problem, and I know it's opposite the velocity, and it just so happens in this problem that that acceleration to the left would be negative, because I've called right positive. I come to a stop, so that's 0. And for v initial, well, what did I start at when I stepped on the brakes? I was going 20, so that's my initial. I don't care about time, so I'm going to pick my equation and solve. Let's see here. It should be v naught squared plus, sorry, v final squared equals v naught squared plus 2a x minus x naught. And then I'll plug in there and solve for displacement. Our v final is 0. Our v initial is 20. Plus 2 times negative 7. And then I'm going to go ahead and substitute in my x2 that I have right there. So x2. I'm going to skip the algebra. If you need the algebra coming after school, I can fill in the gaps. But so 20 squared, and then divided by 2, divided by 7. I'll adjust for the sign. So I'm getting positive 28.6 meters for my x2. So my total here will be my 10.6 plus my 28.6 meters, which is, what is that, 39.2 meters. Let me just double check. It's a Friday. 10.6 plus 28.6. Yeah, that's right, 39.2 meters. So there's my total with X1 and X2 both accounted for, that I travel before I come to a stop. So quite a big distance there. And you can see that when I just reacted half a second, going at 20 meters per second, I went quite a ways, 10 meters. Hopefully I noticed the red light soon enough and that that's not the middle of the intersection. And that's it for problem 29. Just want to check the key real quick, make sure we've got something close. They got 39.2 as well, so we are good to go. If this wasn't clear, feel free to watch again or stop by after school and we can go through it a little bit slower.